Hello guys, so here we're also gonna find a Shapley value. So remember what Shapley value is. We're trying to find an allocation, that is how we're gonna share the utility assigned to the grand coalition, that is in this case this is a coalition of player 1 and player 2 and player 3, and the worth of this coalition is 12. That means we have a utility of 12 to share among player 1 and player 2 and player 3 if they were to play as a grand coalition. And we're trying to find the appropriate value that we should assign given these information. And the Shapley value aims to distribute this utility by looking at their each player's marginal contributions. So we'd expect that more marginal contribution they make in total, the more value, more utility they will get. So in the end, we want to have something that looks like 2, 6. They have to add up to 12, so 2 plus 6 plus 4. So in that case, this adds up to 12, right? So 8 and 12. So that's the utility that they could have got if they were to form a grand coalition. And we're saying that we should assign player 1 2 utility units, and 6 to player 2, and 4 to player 3. Obviously, this is not the answer. I just made that number up, but we're gonna find out how we do it. So keep in mind that we're trying to get that assignment. Okay, so we look at these. So how do we interpret these things? So this v is the value or worth function. So it's gonna show you how much the coalition is worth. So I explained that this means the coalition of 1, 2, 3 gives them 12 utility to share amongst themselves. Okay. Likewise for this one, it means that if player 1 and player 2 were to form a coalition, then they will get 6 utility, and so on and so on. And you can see that if they were to form a coalition by themselves, they don't get any utility. Okay, so in the previous video, we talked about a case where we only have 0 and 1 as a value of the value function. Now we're gonna look at when we have like 0, 1, 6, and 12. So that's not a simple game, as we call it. Simple game means that the value function can only take 0 or 1. Sorry, I'm going a little bit slow, but it's just to consolidate these ideas so you don't have any confusion when you're understanding it. Okay, so this table is here. Okay, so there are 6 ways to order player 1, 2, and 3, right? It could be 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. And what these columns show, these 3 columns show, is how much contribution they get, they make as they are added into the coalition. And this order, so 1, 2, 3, is the order in which they're added to the coalition. So imagine that there's an empty coalition. Okay, so there is nothing. And by definition, the value of empty coalition is 0. So call this coalition, and we're gonna say that at this point, the value of the coalition is 0. Now, we're saying that according to this order, so look at the row 1 where we have 1, 2, 3. We're saying we're gonna add the first player first. Okay, so if we add a player 1 into the coalition, the value of the coalition is what? V of 1, which is still 0. So it didn't change anything. So the marginal contribution of the player 1 being added to the coalition at this point is 0. what if we add 2 into it? So we're keep following this order. We've done first one and we're not doing the second one. So, well, if there are player 1 and 2, then we get 6. So we have 6 here. Because the originally, before we added player 2, we had utility of 0. And by adding the second player, we got up to the value function of the coalition being 6. So it's because of the player 2 that the value of the coalition increased to 6. What about the player 3? So if we add player 3 into the game, what does that make the coalition value to become? It makes it become 12. So it increased from 6 to 12. So it's now 12. Okay, so it was 0 initially, and then it was 6, and it's now 12. Sorry, I was meant to update that. So that's 6. Okay, so I'll go quickly from this point because it's kind of obvious how this one works. So you can see it's like not that hard. It's kind of simple. So order 1, 2, 1, 3, and 2. So when we add the first player into the empty coalition, we get 0. The third player into the coalition, we get, well, we had 1 already. And by adding the third player, it's V of 1, 3. So it's going to be 1. What about putting second player? Well, when we have all of them together, we have margin utility of 12. So you can't, okay, so the important thing to note is this marginal contribution is how much that player adds to the total utility by being added, okay? It's not the value of the function at that instance. So by at the start, there was nothing, and we added the player 1, and that resulted in the value of the coalition still being 0. And by adding player 2, player 3, oh wait, I got it the wrong way around there. By adding player 3, so we have a coalition and we have 1 and 3, and that made the value of the coalition to become 1. So the marginal contribution of the third player is 1. And by adding player 2, we got 11. Okay, that's addition of 11. So I don't think I need any further explanation, and I'll just go on and fill out the table. You can skip it. I think I'll put the timestamp so you can skip it. 2, 1, 3. Okay, so if we start with 2, we get 0. I mean, you can still follow it if you find that more comfortable. Marginal contribution. Okay, so it starts with 0, and we put 1. By adding 1, we have 1 and 2, so it's 6. And by adding player 3, we get 6 more, so that's that. It's the same. And player 3, by putting player 3 into it, we get 1. And by putting player 1, we get 12, 3, 1, and 2. We had player 3 at the start, it gives 0. Player 1 gives also player 1 and 3, that's 1. Player 2, that gives 1, 2, 3, so 11. Oh, made a mistake. Forgive me because I'm still a student. I've just learned about this like last week. Why am I so bad? I don't know. I'm not that bad, right? Anyways, 0, 2, 3 and 2 is 1, and 1, 2, 3 is 11. Okay. Okay, so you're probably wondering, what do you do next? And this is what we do. So basically, so we said we want the allocation of the distribution of the total utility among the 3 players such that they add up to 12, and also 12 as in like they add up to the value of the grand coalition, and also that it's accounting for their marginal contribution. So here's our approach. So for example, player 1, how do you determine how much that guy should get of 12? This is the answer we give. So x1 is the sum of MC1 over number of orders. So what does that mean? Well, we can see that in these 6 orders, the player 1 contributed 0 in the first order, 0 in the second order, 6 in the third order, 11 in the fourth order, 1 for fifth order, and 11 for the sixth order. So basically the sum of these contributions will be 22, 23, 29. So 29. And if we're trying to average that effect out, so because we were taking account for everything, we have to divide it by 6. Okay, so that in the end we'll get 12 of utility in total, because if we add everything together, imagine what that would give. Well, this is already over 12, which was like the amount that was available to everyone. Like the amount that we give to one person can't be greater than amount that's available for everyone. So it doesn't make sense to do that. So we divide it by the number of orders. And so we write 29 as their total. And what about the, just a moment, I'll just erase this column out and say xn. So it's just gonna be 6 plus 11, 11 and 1, that's going to be 17, 18, 12, 23, and 29. Oops, 29. That's going to be, that player 3 is going to be 6 plus 1, 7 plus 7, it's 14. So 29 and divided by 6, and 29 divided by 6, and 14 divided by 6 is how much they should get in total. Okay. I mean, in their, so what I've just written here, right? So x is 29 over 6, 29 over 6, and 14 over 6. So we're saying that in the grand coalition, if they were to even form a coalition together, which means that they will be having 12 as how much utility they can share amongst themselves, they should allocate that utility in this manner. So player 1 gets that much, player 2 gets that much, player 3 gets this much. How do we confirm that they add up to 12? Just add it up. So 29 over 6, 29 over 6, 14 over 6, which is just 40, 50, 58, 58 over 6 plus 14 over 6, 60, 72, 72 over 6, which is 12. So we confirm that these all add up to 12, and that's feasible allocation. So we're not missing out on any utility that we had for grand coalition, and we're distributing according to their marginal contribution. So it's good. It's all good. I think that's it. So that was a recording on coalitional game. I mean, Shapley value, finding Shapley value for a coalitional game. I might try make one for a more difficult core coalitional game for finding core. And there's assignment problem and there's marriage problem that we want to solve as well. So you can keep an eye on that. Cheers.